realized it much later that indexing itself takes a lot of space. Indexing in itself, you can't index for every query that you write. You need, okay. First of all, good afternoon, everyone. I hope the lunch was good, but obviously not too good so that you don't sleep off while I give this talk. And welcome to my presentation of how we use Postgres in Zerodha, and what have we learned from it, and our mistakes, our experiences, everything, and where we are right now. So setting up the context for the talk, to quote my favorite Salman Bhai movie, Race 3, our learnings are our learnings, none of your learnings. What it means is that everything that I'm going to speak about here is something that we have learned in our experience in the context of the data, that how we use, how we import. It might not apply to even one person in this room, and that is how databases should be. It should not be extremely generic either. You might disagree or be triggered by how we use Postgres, and that is okay. I've been told by Kailash, our CTO, to not make any jokes, even PG-13 ones. A little bit about me. I've been at Zerodha since day one of tech team as the 10x engineer. These are all memes that we have internally about each other, and been managing the backend, full stack backend for the entire time I've been at Zerodha. Gone through all possible databases, MySQL, Postgres, Redis, MongoDB, ClickHouse, Cockroach. The list is endless. And before I get into this talk, I first of all like to, say thanks to the core team of Postgres, because I've come across multiple languages, databases, softwares, Force or Enterprise, but I don't think there has been anyone better at documenting their features as well as Postgres has done. I don't think there is anyone that has a better blueprint of what they want to do in their future updates like Postgres has done. I don't think there is, I might be wrong here again, because as I said, it's our learnings, but I don't think there is anything as resilient as Postgres has been for us. And we have done ridiculous things with it, and it has just worked. From upgrading from Postgres 8 is where we started to Postgres. We are right now at PG-13. And it has, the updation has never caused an issue, no data loss, nothing. And that is, cannot be more thankful to the core development team of Postgres and the community of Postgres, which has always been super nice in answering any of our doubts on the Slack channels. So, history of Postgres usage in Zerodha. We started out, first of all, let me set a bit of context of how Zerodha imports or uses its data, and maybe that will be helpful in understanding why we do things with Postgres the way we do it. As you know, Zerodha is a fintech Indian broker. Maybe I should have introduced Zerodha first. I don't think everyone knows what Zerodha is. So we are a stock broker. Robinhood of India, or Robinhood is Zerodha of US. We deal with stock market, and we import trade books. We basically build a software for people to trade on, so which means that we have to deal with all kinds of financial information, and that also means computing a lot of financial information, like P&L of profit and loss of users, how much, the ledger of users, how much money they have transferred in, transferred out, all critical financial information that we store, and we use Postgres for it. Markets are open from 9:15 to 3:30 every day. After that, M6 is open, but I don't think we ever cared a lot about it. But yeah, markets are open from 9:15 to 3:30 for most of our traders. And our systems that we have built, some of them are read-only throughout the day and become write-only at night. Many of the systems that are built are usually read and write throughout the day and night, but our systems are a bit different than that. And the systems that I have worked on, we have a trading platform called Kite, which has a transactional DB, which again uses Postgres. That is a read-write throughout the day. but console, which is our back office platform where all the trade books, all the information regarding anything the user has done throughout the day on our trading platform gets imported in. That import happens at night. That is, the writes of bulk writes happen at night, but majority of it remains a read-only platform throughout the day with very few writes. So that is the context on which we built our schemas, our queries, our databases, and how we scale. So we started off with importing around, so when I joined, Zerodha used to have 20,000 clients. Not even all of them were active, and we used to import around 100, 150 MBs of data per day at best. And I used to have, I am saying I a lot here because at that point of time it was just 2 or 3 of us. I mean, if you have read our blogs, you would know that we're a very lean, very small team, and we still have remained so like that. So I used to face a lot of issues with scaling even that 100 MB of data when we started out with. When I look back at it, a lot of things that I did was extremely obviously dumb, lack of understanding of how data works, lack of understanding of how databases work, over-indexing issues, under-indexing, everything, every possible thing that you can think of can go wrong in a database. For example, let's say the log files overflowing and causing the database to crash. So everything that can possibly go wrong has gone wrong with us. We have learned from it. We've improved our softwares, our way we deal with storing our own data. So started off with 100 MB, 100 MB failed. There was Postgres 8. Improved on our schemas, improved our schema design, improved the way an app has to be built on top of our databases. Not rewrote our apps multiple times. Again, if you have read any of our posts, you would know that we rewrite a lot of our things multiple times over and over again. It is mundane, might be, but it solves a lot of headache for us by removing legacy code, legacy issues, and I would say legacy schemas too, because you might have started with a schema that doesn't make sense right now because your queries have changed, the way you deal with the data has changed. So we end up rewriting everything. We know that nothing is constant, everything will change, needs to change, everything will break, and that's okay, we are okay with it. We currently deal with hundreds of GBs of import every single day. Absolutely no issues at all. I mean, there are plenty of issues, but Postgres has worked fine for us till now, though we have other plans of doing other things with it. But till now, again, nothing as resilient, as good as Postgres has been for us. So how do we manage this big amount of data? I've put a question mark there because when we started out understanding our data better, I remember this was 6 years back probably. I remember sitting with Nitin, our CEO, and even Kailash, and Nitin used to be like, so we are very close to big data, right? Because big data used to be this fancy term at that point of time. I never understood what big data meant. I assumed that it's just a nice-looking term on your resume, right? You're managing big data. Eventually, I guess we all realized that all of that is pretty much hogwash. There are companies which need big data. There are companies which don't need big data. You don't have to be a serious engineering company. If you don't need to have big data to be a serious engineering company. You can make do with little less data. So this talk is probably going to be a bit of an overview of how we manage our data till now, but I'll be more than glad to take questions at the end of it if there are more doubts or anything else. First thing is index, but don't overdo it. So when we started out, I thought that indexing was like a foolproof plan to solve everything that is there. Realized it much later that indexing itself takes a lot of space. Indexing in itself, you can't index for every query that you write. You need to first understand that there are some queries that need to be fast and some queries that you can afford it to be slow, and that's okay. So how we have designed our systems is the queries that are the number of queries are higher for, let's say, a particular set of columns. Those columns are indexed. And the columns that are not indexed, they might be queried, but we don't index them at all, and that's okay. Those queries might take a long time, but they're not user-facing. They are back-end repos that get generated over time. Not everything has to happen in 1 second or half a millisecond or stuff like that. So we are very aware of that when we index. We use partial indexes everywhere. That's another thing that we learned, that even if you're indexing a column, you can partial indexing will be much more helpful for you in categorizing the kind of data that you want to search. The second thing is materialized views. I'll combine materialized views and the denormalization point into one. The reason being, if any of you have done engineering here, you would have studied database systems, and one of the first things that is taught to us is normalize, normalize, normalize everything, right? And when we come out, we come out with this idea that we need to normalize all of our data sets. You'll realize that this works well on smaller data. As the data grows, those join queries will stop working. Those join queries will become so slow that there is absolutely nothing you can do to fix it. So we took a conscious decision to denormalize a lot of our data sets. So majority of our data sets, majority of our tables have nothing to do with each other, and we are okay with that. It obviously leads to increase in the size of data that we store, but the trade-off that we get in improvement of query is much higher than the size increase. We can always shard and make our database smaller or delete data or do whatever, but query improvement is a very difficult task to pull off if your entire query is a bunch of nested joins across two heavy tables. We avoid that everywhere, and one of the ways we avoid it is, obviously, as I said, we denormalize a lot, and we have materialized views everywhere in our system. And that is one of the easiest, cleanest, fastest way to make your queries work faster. If there is a bunch of small data set that is getting reused all over your Postgres query multiple times over, use with statements, use materialized views, and it will be, your queries will automatically be fast. I don't want to give you a statistics about 10x fast or 20x fast and all, because it again depends upon data, your query, your server size, all of those things. So no metrics as such being thrown here, but it will have a much better experience than doing multiple joins across massive tables. Avoid that at all costs. One more thing is understanding your data better, and by that I mean, I feel like, and this is something that I've learned after talking to a lot of people of different companies or different startups and how they work, and they pick the database first, and then they figure out how to put the data into the database. I don't know why they do that. Maybe the stack looks more rock star-like, I guess, if you choose some fancy database and then try to pigeonhole the data into it. First understanding the data, then understanding how you will query the data should be the first step before you pick what kind of database and how you will design the schema of the database. If you don't do that, if you say that, you know what, it's a Postgres conference, it's going to be just Postgres in my stack, there will be nothing else, nowhere. Postgres is like the one true solution for everything, so that's not going to work. Then the next point is Postgres DB tuning around queries. One more thing we have realized is many people tune the database. This is something that I came across again very recently while I was dealing with another company, database stack. They have tuned their database in a wholesome manner. That means that the entire database has a set of parameters that they have done PG tuning for, and it caters to every single table that is there in database. And that is a terrible approach if you have a lot of data. A better way to do is you tune your DB, there's no denying that, but you also tune your tables. Maybe a particular table needs more parallel workers. Maybe a particular table needs frequently vacuumed compared to the other set of tables that you have in your DB. So you need to tune based upon the queries that hit those particular tables rather than the entire database in itself. The last, understanding a query planner, I'm sure there is what is a mistake? Understanding a query planner. So another mistake when I started out was, I'm sure, I don't know how many of you feel that way, but a query planner of Postgres or any database is a little hard to understand. And I felt that for the longest time. It will just print a bunch of things, and all I will read is the last set of things, right? So it took this much time, it accessed this much data, and that's all I understood from those query planners. Took me a very long time to understand the direction of the query, which is very, very important to understand. Direction of the query would be what is called first, a where clause, an and clause, a join clause. In your entire query, if you do not understand that, you will not be able to understand your query plan at all. And it's very easy to understand a query plan of a simple query, right? If you do a select star from whatever table and fetch that, you don't even need a query plan for that. If the database is, if the index is not there, the query will be slow. You don't need a query plan to tell you that. But query plan is super helpful when you're doing joins across multiple tables, and understanding what kind of sorts are being called is very, very important to understand. I think me and Kailash must have sat and debugged multiple queries trying to understand the query planner of it all. And Postgres is very funny with its query planning. So there will be a certain clause in which a completely different query plan will be chosen for no reason at all. And you have to, and there have been reasons where I still don't understand some of the query plans that are there, but we have backtracked like into a explanation for ourselves that if we do this, then our query plans will look like this. And if we do these set of things, our query plans will look like that. This is better than this, we'll stick to this. And we have followed that everywhere. And I don't think you can look at a documentation and understand a query plan either. This is something that you have to play around with your queries, play around with your data to get to the point. The queries that I would have in my system on my set of data would have you reduce the data by half, and the query plan will work very differently, just the way Postgres is. And that is something that you have to respect, you have to understand. And if you don't understand query plan, forget about optimizing your queries DB schema. Nothing will ever happen. You will just keep vacuuming, which brings me back to the last point. And this is funny because I was in the vacuuming talk, the one that happened right before lunch break. So the first thing he said was, do not turn off auto vacuum. The first thing I would say is turn off auto vacuum. So, and I'll tell you why we do that and why it works in our context and might not work for someone else. Auto vacuum is an incredible feature if tuned properly. If you have seen the tuning parameters, they're not very easy to understand. What does delete tuples after X number of things even mean? They're not easy to, what does nap time mean? How does someone who has not dealt with database for a very long time understand these set of parameters? There is documentation and all of that, but it's really hard to read an abstract documentation and relate it to a schema. We played around with every single parameter that auto vacuum has. Nothing worked for us, and I'll tell you why. We would bulk import billions of rows in a fixed set of time. Now you might say that, well, if you are importing everything in a fixed set of time, why don't you write your auto vacuum to work right after the import has been done? That import is never under our control. The files can come delayed from anywhere, any point of time. And because none of it is under our control, we decided that auto vacuum is not a solution for us, turned it off, because it was going to run forever and ever and ever. We vacuum, so I hope most of you know the difference between vacuum full and vacuum analyze, but if you don't know, vacuum full, a very simple explanation, vacuum full will give you back your space that you have updated, deleted. Vacuum analyze will improve your query plan. We don't vacuum full anything because that completely blocks the DB. We vacuum analyze all our queries right after doing a massive bulk import. We realize that, I'm sure if you have been in the talk, he spoke about max parallel workers while auto vacuuming. We understand that auto vacuuming uses the parallelism of Postgres that is inbuilt into it, which we don't. But we don't really care about it because this happens late in the night, and vacuuming taking half an hour more or 10 minutes more doesn't make a big difference for us at that point of time. So in this context, in this scenario, turning off auto vacuum and running vacuum on our own as a script that triggers vacuum for multiple tables, one after the other, once our imports are done, works for us. But to reiterate again, it might not work for your context, and maybe auto vacuum is the better solution. But remember that auto vacuum has a lot of pitfalls, and I read Postgres 13 documentation a while back. It still hasn't improved to an extent that I thought it should have by now. And it still has its set of issues while dealing with massive sets of data. But I hope it gets better over time, and if some core developers can do it, then it has to be Postgres. So I hope they do that. So yeah. Okay, so this is another interesting part of the talk, I guess. But before I get there, I remember speaking to someone outside, and they said that, how is your setup like, and what do you do for Replica and master slave and all of those set of things. So I guess this will be triggering for everyone. We don't have a master slave at all. We don't have a Replica either. We have one database and one node. We have started it using foreign database wrapper. Why we have started it like that, I will explain. I'll get to that. But we have started it using foreign database wrapper. So we have divided our data across multiple financial years and kept older historical financial years in a different database server and connected both of them using FDB. And we query the primary DB, and it figures out from the partitioning that the data is not in this database server right now, and it is in the other database. It figures it out, fetches the query for us, fetches the data for us. No slave setup. Our backups are archived in S3. We are okay. This is, by the way, to reiterate, this is a back office platform. We do not promise that we'll have 100% uptime. We are okay with that. We understand that if Postgres goes down, which has never ever happened, again, thankfully to Postgres, but even if it goes down for whatever number of reasons, we have been able to bring that back up, bring the database back up by using S3 within minutes. And I have restarted Postgres that is pointing towards a completely fresh backup from S3 with maybe 15, 20 terabytes of data under a minute or two. So it works. So there might be fancy, complicated, interesting setup to make your replicas work, but this also works. And many people might call it jugaad, hacky way of doing things, but I don't think it is. I think it's a sensible approach. We don't want to over-engineer anything at all. If this works, why have a bunch of systems that you need to understand just to manage a replica setup? Now, coming back to the question of, if we don't have a replica, how do we load balance? We don't. But what we have done differently is that we have a second Postgres server that sits on top of our primary DB and acts like a caching layer. We have an open source piece of software called SQL Jobber, which is a async job-based mechanism that keeps polling the DB and then fetches the data, stores it in another Postgres instance. And then eventually our app understands that the fetch is done, data is ready to be served, and it fetches the DB, fetches the data from the caching layer. So we end up creating around 500 GB worth of, I would say around 20, 30 millions of tables per day. I remember asking someone in Postgres Slack a long time back that we are doing this thing where we are creating 20 million tables a day. And they're like, why are you doing this? Isn't there another way of doing it? And we're like, no, this works. And the reason why we do this is because Postgres in itself supports sorting, which Redis doesn't. Postgres, at that point of time, it lets us do pagination. It lets us do search on top of trading symbols if we need, search on top of any columns that we need to do if necessary. So we have Postgres sitting as a caching layer on top of our primary Postgres. And all the queries first come to the SQL Jobber application. They go to our primary DB. nothing gets hammered to the primary DB, though, so the primary DB is not under any load at any point of time. I mean, there is a query load, but it's not getting hammered at all. The hammering happens to this caching DB, which gets set eventually at some point of time with the data. And then we serve the data to our end users, and that remains for the entire day. Because, as I said, during the day, the data doesn't change a lot. So we can afford to cache this data for the entire time duration. There are some instances in which we need to clear the cache. We can just delete the key, and then this entire process happens all over again for that particular user. So that's how our Postgres caching layer is. Has worked fine for us. Every night we clean the 500 GB. So how we do is every night we have two 500 GB disks pointing to the server. We switch from disk 1 to disk 2. Then the disk 1 gets cleaned up. Then the next day goes back from disk 2 to disk 1. And again, the new tables are set all over it again. Works fine. Never been an issue with this. Coming back to our learnings with Postgres. Yeah, sorry. Can you take that one here?
Hello? Are you able to hear me? Yeah. You're telling that about Kite platform. So from the Kite platform data, that is OLTP environment, right? So from the Kite platform data, you are porting to the console database.
Yeah.
So that is a nightly job.
Yeah, that's a nightly job. That's a nightly job. Yeah.
So that's what you are telling in the console system that create millions of data, right?
Yeah. So okay, maybe I should explain this again. So you place your orders, your trades, and everything on Kite, right? At the night, we get a order book or a trade book that gets imported into console. We do that to compute the buy average, which is the average price at which you bought that stock, or the profit and loss statement, which you'll use for taxation for any other reason that you might need it for. That is why we import data into console. So to fetch these set of statements, you have to come to console to fetch that. Now, when you are fetching the statement, this caching layer sits on top of that. Your fetches go to this caching layer first. It checks if there is already a pre-fetched cache for you ready or not. If not, the query goes to the DB. The data is fetched, put into the caching layer, and for the entire day, the caching layer is serving the data to you, not the primary DB. The primary DB remains free, at least for you as the user. So let's say you come in, you play around in console, you load a bunch of reports, everything is cached for the entire day in this caching layer. So primary DB remains as it is till that night. So that night would have gotten all the trades, orders, anything that you have done on your trading platform into console. We import all of that. We clear our cache because it's a fresh set of data. Your P&L, your ledger, your financial statements have changed because maybe you would have traded that day, maybe you have bought stocks that day, or anything would have happened to your account that day. So we clear our cache. Then next day when you come and fetch the data again, all of this is set all over again. And then whenever you can keep revisiting console, keep fetching whatever amounts of data you want to, it will come from this cache. Unless, of course, you change the date parameters. Only then we go and fetch the data from our primary DB. But we have realized that most users use the data of a particular time frame, and they don't want to come and check for last 3 years what has happened. It is always in the last 6 months, last 2 months, last 1 month, and they check that once, they go back. And we cannot obviously build a system where every single date range has to be equally scalable and equally available. We are very aware that the older, which I'll talk about how we have sharded, we are very aware that our older financial year data points don't need to be available all the time at the highest possible metrics of a server. They don't have to be served at a very fast rate either, right? So these are the decisions that we have taken, and it has worked fine for us. Might not work for another person, but yeah. So I hope that answered your question.
One doubt on that.
Yeah,
Kite
please.
is also having Postgres DB, right?
Yes.
So you are using PG dump or Postgres utilities itself?
No. So Kite uses Postgres for its MarketWatch. So MarketWatch is the place where you add different scripts or different stocks, and it tells you the current price of the stock. Though we have plans of moving away from that to ScyllaDB. That has got nothing to do with this. How I mean, I guess you're asking a more of a how a broker works question or how a trading platform works, but you place an order. The order comes as an exchange file at the end of the day for us, and we import that. So there is no PG dump that happens from kite to console. So those are completely two different silos that have very little to do with each other. They rarely share data among each other. And they're never in the hot path because we understand that kite is a extremely fast read and write platform where everything has to happen over milliseconds and it can't ever go down. So these set of fundamentals will not really work there. So there is no connection of PG dumping kite data into console. Kite works throughout the day, console works after the day. After your trading market is done, that's where you come to console and check how well you have performed in the day. So does that?
This caching layer, do you have in Kite also?
Caching layer on Kite, yeah. It's Redis. It's predominantly Redis caching layer. So we also use caching, Redis caching on everywhere actually. It's not just Kite, we pretty much use Redis. Like if you have used our platform Coin, it used to sit on a $5 DigitalOcean droplet for the longest possible time because everything was cached on a Redis instance and used to work just fine. So we use Redis predominantly to cache. We don't use Redis in console for these kind of caching layer because sorting and pagination is not supported on it. This is a very specific requirement here. It works here. So we use Postgres here for that. Is it fine?
Yeah, I used this Kite and console. That's why I asked this.
Cool, no issues.
Thank you.
So our learnings with Postgres, and I'll start off with how we, because I remember my summary of my talk that is there on the posters and etc. outside talks about how we shard and why we shard the way we do it. If you have seen Citus DB extension or a lot of sharding examples all over the world of all the DBs in the world, how they set it up is have a master DB, have a parent DB or whatever, and have tenets to every single child that is connected to it. Now, how those tenets work is that you query the master DB, it figures out that these set of tenets are in this child setup or this sharded setup, and the query goes there. We believe that there is no reason to add another column that has these IDs on it. We actually, in most of our tables, we have deleted all our IDs. Extra data, don't need it. So we follow that in a lot of places. So what we decided was that we partition our database per month because it works for us. Then for every single financial year, we put it in a different database server, and we connect it via FDB wrapper. And that is our entire sharded setup. Has worked fine for us. But I would say that at our scale, and our scale is 30, 40 terabytes or 50 terabytes, you can say right now. It's starting to falter a bit. It's not a great experience anymore, and which is why we are moving to a very different setup, different way of sharding. Maybe that is for another talk, but till now we could scale to millions of users serving billions of requests, 500, 600 GBs of data per day using just foreign data wrapper and a SQL jobber caching layer on top of our primary DB. No nodes, no load balancer, nothing at all. So our learnings of Postgres has been that this is something that is a gut feeling when you write your queries or when you look at a database schema, that our gut feeling is that every query has a time to it. Like for a particular amount of data, for a particular query should not take more than X number of milliseconds. I guess that comes with experience. Many of you can just look at the data, look at the query, and know that something is wrong. Even if it's slow by a few milliseconds, you can figure that out. So we have a hard limit that certain queries cannot cross this limit, and we optimize and keep on optimizing based on that. Most of our heavy queries are in an async setup, like the jobber cache you said. We ensure that none of it is on the hot path of an app. There is no glory in storing too much data. So we delete a lot of data. So someone was surprised that our total database is 50 terabytes, or Yeah, probably around 50 to 60, not more than that for sure. And one of the reasons why it is 50 and not 500 terabytes is we delete a lot of data. We do not believe in storing data that we do not need. What does that mean? Is that we, for most of the computations that we do, for most of the imports and inserts and everything that we do, we have a hot backup, or whatever you can call it, of the last 15 days, or last 15 days. After that, we have checkpoint backups of last 1 month, last 2 months, last 3 months, one backup for each month. We do not have any backup in between any of those dates, because we can go back to any single month and regenerate every day's data till now. We are okay doing that because we have that a night where if anything can go wrong and we can run these set of computations and come back to the current state that is right now. Maybe it doesn't work for others, but this is another experience that I've learned looking at databases of others, that there is a lot of frivolous data that people like to keep for no reason at all, because it just makes the database looks bigger and, I don't know, makes it looks fancier. Just delete it. It doesn't, back it up in a S3 and put it somewhere. Like, don't have to be in a database. Why does 6-year-old data, unless it's a compliance that is being set by the company you work for or the organization you work for, unless it's a compliance that you have to do it, it can be an S3 backup. It can be a file. It doesn't have to be in a database, and you don't have to be responsible for every query of last 10 years to be served under 1 millisecond. It doesn't make sense. It will never scale. Don't do that. The other thing that I've also noticed is a lot of people write, maybe this is a front-end developer going into back-end issue, where a lot of the logic that should have been done by Postgres gets done by the app. And I've noticed that in a lot of places, and I think that is something that fundamentally should change. Postgres in itself can do a lot of computations, like summing, average, window functions. You can do so many things by overloading into Postgres rather than your app doing it. And I find that strange, because your app should be responsible for just loading the queries, fetching the data. It should not be computing for most of the scenarios. I don't know why this is something that we had done as a mistake too, and we learned. And I hope that if there is only one learning from my entire talk, because I've noticed this in a lot of places, is to overload your Postgres with most of the computations. It can do it faster than any app that you write, unless, I don't know, you are using R or something else, but still Postgres will be really fast. So try to do that. And as you would have noticed that our engineering setup is very lean. It's not overwhelming or underwhelming, it's stay-whelmed, I guess. We don't overdo anything at all. We always hit the limits of what we have right now in every possible way, and only then look out for other solutions. And it has worked pretty good for us. We have never over-engineered any of our solutions till now, and we have always organically found solutions for whenever we have come across issues. If Postgres hasn't worked for us, then that's fine. We'll find another solution for it. So as I said, sometimes Postgres might not be the answer. Sometimes a different database would be the answer for you, and you should be, I guess, humble enough to accept that and move on from Postgres. Most databases are very similar to each other. If you go through how they design the data, how the schemas are made, unless you're dealing with columnar databases, they're very similar. And the fundamentals remain the same across all databases. If they are not, then that is a wrong database. So we're nowadays experimenting with ClickHouse a lot, and the fundamentals are very similar. So do not be afraid to experiment with a different set of databases. We all do that a lot in our free time, because it's a strange way to, I guess, end the talk, but Postgres might not be an answer for every single problem, though we found an answer for a lot of our problems, and you should be okay with that. Thank you.
Hello. So even if the application uses R, you can have R inside Postgres. So that solves the problem anyway. But my question is, when you say the caching layer has 20 million tables, how do you take care of the catalog load, or do you just drop and recreate the whole cluster every night?
Yeah, we just RMRF the entire data.
Okay, fantastic. Yeah, that's what I was thinking. The other problem is, even with that, I've had scenarios where you run into EXTFS or whatever, file system related limitations on, because like Postgres stores everything in a single directory, right? Yes. So have you had hit something like that? And if so, what do you do?
Yeah, I mean, I would categorize it as some of the mistakes we did at the beginning. The file limits were wrong to begin with, but post that we have never really come across any file limit issues. We have, I mean, more than happy to admit it, we have come across issues where we've run out of integers for our ID because that's the number of columns we stored in one single go. That also has happened. So, and then the import stopped, then we had to do a ridiculous amount of things, you know how much time would have altering that table would have taken. But no, we didn't, it was a server configuration mistake that from our end, but it was never the issue of Postgres. So I haven't come across it in my experience.
Okay, thank you.
So you said you hardly have any crashes or any downtime. So is it with some kind of a HA solution, or it's just the instance doesn't crash? Or what's the magic?
Oh, what's the I mean, I think the magic is by the Postgres developers. No, I think the reason we don't have a lot of crash is we have ensured that all our apps are not sitting on top of massive databases. They're always sitting on top of caching layers, one. You cannot ever scale an app on top of 10, 20 terabytes of data and expect it to work without crashing. It will crash if that happens. It will overload. And we have crashed our databases. But the mistake was not of Postgres. That is wrong to expect that. The mistake was that we thought our app can easily query that much data in this much amount of time and be fine with it. It will never work. As soon as we made it async, as soon as we made it behind a caching layer, it worked absolutely fine. So it's, again, there's the same answer. It wasn't the issue of Postgres. It was our mistake that we had to rectify.
Thanks.
Okay, so we'll take last questions. After that, you go offline questions.
This is regarding today's morning session, right? Like Kailas was addressing that before COVID, you could able to take 2 million requests, and during COVID, like you are able to scale up to 8 million to 12 million without scaling your system. How did that happen?
Okay, I'm going to sound a little dumb here, I guess, but caching is the magical layer on top of everything. I guess we were already ready to serve. We did increase our primary DB servers, the number of cores, number of parallel workers that query the database. All of those tuning had to change, obviously.
Now, was it over-provisioned?
No, it was never over-provisioned. It was always 1 DB. So there is no over-provisioning 1 DB. It's not like it was multi-sharded setup. So it was 1 DB. We added more cores to it. The jobber is a separate server that runs, the caching server that we call it, right? So that was never over-provisioned. That is still, whatever we started with, it's the exact same setup till now. 16 cores, 32 GB RAM, still now. And that's how we started 3 years back. Works fine. I don't know, man. I guess that's how good the caching layer is. You can say that probably we over-provisioned before that, because when we by default start with this 16 cores, 32 when you're dealing with a Postgres DB, because we are used to tuning it for that. So we know the tuning parameters for those set of numbers. So that's why we start off with that. Usually in that case, maybe that's why we started here like that. We thought that it would work fine.
Have you ever forecasted that?
Have you ever?
Forecasted that load?
Sorry, you couldn't.
Load
tested. Yeah, couple of times. The maximum load that we have gone to was 4 or 5, and that's it. It's never been more than that. Our Postgres database has been overloaded multiple times, and every single time it has been overloaded has been our mistake, where we have skipped the caching layer and hit the database directly. And as I said, that will never scale. It doesn't matter if it's 1 terabyte or 500 GB. It'll not work. So we have, every time we consciously write a new API endpoint, we ensure that the first frontier has to be the caching layer and sitting on top of it, and everything has to be async. It cannot be concurrent. It cannot be concurrent queries hitting the DB and an HTTP API endpoint waiting for the response to happen. again, that will not scale. Your app will go down for sure. Eventually, everything will be in a wait IO situation and nothing will work.
Thank you.